Hello everyone, thanks for checking out this video. I'm going to talk to you about using Git and GitHub when we're doing our programming and using the RStudio software. So I'm calling this talk R is to RStudio as Git is to GitHub. That means as we learned, and if you watched the previous videos, you saw that R is a scripting language that we interface with through the RStudio tool. So RStudio being a software developed by a company, and R being an open source language. Git is similar, open source language, a way to communicate with your computer and do version control. And GitHub is a company, a software that's developed to interface with that language. Very useful, friendly community, similar in many ways. And I hope you find this useful. This is how you contact me if you have questions or concerns about any of this. And I wish you a lot of luck in following this tutorial. Take it slow, pause a lot if you need to. So Git is a way one of the many ways to do automated version control. It's our favorite one. It's the one I mostly use. And I've linked you here to a novice guide, the GitHub SW Carpentry GitHub novice guide. That's a good starting place to learn about some of the entry-level ideas for Git, but I'm going to walk you through some of the very basics here. So let's play Never Have I Ever. Never have I ever used Command Z or Control Z. Even sometimes in reality, I have to admit, I use Control Z. You know, the coffee spills, I knock it off the table or something, and then I say, oh wait, Control Z. Like even filters its way into reality for me in some ways. Of course, it doesn't work in the real world, but it sometimes works when you're writing a document or something. Never have I ever come to the office, but left the work at home on another machine or a USB, or I tried to co-author scripts by emailing files back and forth. All of these things can be difficult, painful, and they don't always work the way that we expect. Having things on USBs or emailing files back and forth. Sometimes there's a version conflict, if you've ever had this, where two authors maybe respond at the same time to a set of, and they disagree, and what do you do with this? So Git is a way it's an open source version control tool, and GitHub is a company that hosts something called repositories, that is a collection of files related to a certain project. And it provides a web interface to interact with those repositories, what we call repos that they host. So I'll show you how that all works just through their native tools. This is this is a comic from phdcomics.com. If you haven't already checked it out, then definitely do. And this is something that probably all of us have been through. This used to be how it worked. You'd say final .doc, and then the professor marked it up. Final revisions 2, final revision 6 comments, and finally you've got final revision 22 comments, 49 corrections, 10. Why did I come to grad school .doc? So there is a better way to do this. So the Git overview. Git, as I said, is more or less the language. Here again is a website you can visit to learn more, https://git.scm.com. Git is a better way to undo changes, to collaborate, then mailing those files back and forth, and to share code and other work with this scientific work with the world, that is to link people even outside of your group to the repositories that you create. So an overview, just to give you in on some of the terminologies. Your repository, that is your collection of files that you're keeping in this, that you're sort of backing up in the system, consists of trees that are maintained by Git. The first one is your working directory, which holds the actual files. The second one is the index, which acts as a staging area. And finally, the head, which points to the last commit you've made. I'll walk you through those different trees, but here's how they work. You've got your working directory, you've got your index, and you've got your head. So working directory, that is locally, you have a file where you're keeping things stored. You can, as you make changes to this, you can add them to this index, commit them to this index or store them in the index. That is, all the changes are kept locally, you can see them, and then you can commit these, that is, send them to the repository online. So back up what you have locally with the online or the common version that everybody else can access. That'll become more clear, I hope, as I go through this tutorial. So using Git and GitHub, you are going to get stuck. Unfortunately, there's a bit of a learning curve, and it does take some time. And as with R, there are resources when you're getting stuck. So if you get stuck at Git to a search query in any of your favorite search engines, and with a short description of your issue, you'll generally find that someone else was also confused by this. They also had issues with it, and they've also written about it. And again, as with R and other software, there are thousands of talented programmers who scan the web and answer questions about these problems. And you'll probably find something on Stack Overflow, that's stackoverflow.com, but you can check another website for resources as well. And I would do a general search query first to check those resources. See if it's on any other websites. So the first thing you'll need to do is to install Git and also join GitHub. Those two things are prerequisite to getting these working on your machine and having an interface with the online repository. So you can install Git at git-scm.com/downloads. We can just open that now and see what it looks like. So here you'll see in the Git, it's distributed is the new centralized. That's their tagline. And here you'll find, so I just automatically get the latest release for Mac advertised here to download. It's free. You can get an older release if necessary. If you're using Linux or Windows, you can also find that information, those tools here for the download. And if you already have Git installed, you can get the latest development version via Git itself by copying this code git clone github.com git/git. So I'm just going to go. So what I'll do is I'll go to RStudio, and I'll go to my terminal. So you've got console, which is what we talked about in the past tutorial. Console is where you can interface with R directly in RStudio. Terminal is where you can interface with your machine, and I'm just going to type here. I'm just going to copy paste, actually. I could type it up, but git space clone space https github.com git/git. So this will install the latest Git. Otherwise, go to the website git-scm.com/downloads, and you will find your version to download there for the first time. The next thing you want to do is to join github.com. I think if I open github.com, you're going to have to sign up. So you're going to have to generate a profile. And you may have to verify your account with some kind of, it seems here now they've got a puzzle in place, so you're going to have to create a username. Do that carefully. Think about something that you think is good. For a username, this is going to be your handle. It's like your Twitter handle, but in shared repository, so think of a good name. I would use a common email. I think you can add multiple emails. I'll check that now, actually. Let's see, GitHub. So I call myself C.W. Whitney. My middle name is William, so Cory William Whitney. C.W. Whitney. And so people can find me relatively easily and they're going to use that handle. If they want to mention me anywhere, they can use at C.W. Whitney to let me know that they have issues. Here you can use your institutional email address or any other. And if you want to add more email addresses, that's also possible. So don't worry about being permanently linked to a specific email address. Within your profile, once you've set one up, in the upper left, on the upper right-hand corner, rather, you'll see settings as a drop-down, and then in settings, you'll have public email and email settings. So you can set your public email to whichever one you want. And then I've set also my Gmail account and my Unibond email account here in my settings. Once you have Git and GitHub installed, you can look through some useful tutorials other than this one, maybe even much more in-depth and more useful once you get these things working. There's some useful tips from the University of Zurich. They walk through a reproducible workflow for a research project, an example research project. And Nathan Stevens, who actually is doing lots of different types of blogging on R, very much worth a read. And on support.rstudio.com has an article on version control with Git and walks through the use of something called the SVN, which is a reference to previous versions of repository. I also recommend that you go through the Hello World. So on GitHub, they have, of course, because GitHub is a commercial website, they have something called the Hello World, which is common in the world of programming and software development. So whenever a new application is developed, then they typically make a hello world so that it's easy for someone who's interfacing for the first time to really see all the functionality of this particular tool. Actually, one thing that's important there when you're thinking about this as a commercial website is that they do have a number of features that you could pay for. The same is true for RStudio, as you saw. And with a university email address, with an affiliation with a university, you can actually get most of those features for free. So I do recommend looking into getting an education account. It's different in different locations, different regions, but generally, once you have a university email account associated with your GitHub account, then you can go through a number of steps to get an education account, and I highly recommend that. GitHub is even easier than Git because it doesn't necessarily require memorization of command line tools. I will show you a few of those that we do use commonly that are good to know, but generally you can get around interacting directly with the command line if you're not comfortable with that and you don't memorize command lines. And there are lots of useful features when you have a repository like issues and wikis and the README file, as you'll see. So it's a repository hosting service, and the service is pretty dynamic, lots and lots of features to proclaim there. Again, look at the Hello World and try to see really how general, it is very straightforward. In fact, it's not necessary for me to show that here, but I do recommend that you visit guides.github.com/activities/hello world and walk through that process. It'll show you really clearly how to create a repository in the first place, how to make changes to that repository, and how to share those changes around, and how to do changes in sort of different tracks, that is, in these branches that we talked about earlier. So a few things that I do work on in the command line is, and you can learn more about these command line options on git.svn.com again, but so if I want to back up just one, let's say I made some commits and I'm not sure that I like those, then I can use git reset soft head 1. That means go back one step. So let's say I made some local changes. By the way, these slides that I've been showing here are available as in the GitHub repository, so you can have access to these. I've written them in some of the kind of tools, native tools to similar to Markdown. It's just our Prez document. And you can have this as a GitHub repository. I can give you access and you can have this very same collection on your machine. Won't that be great? Yeah, and so we've got here in the terminal, as you saw earlier, I put some notes there about updating my Git. Well, I can also put these commands git reset -- soft head 1, and what it would do if I did that, I'm not going to do it right now, but if I put that into the command line, it would let me back up one commit. So one commit ago, I changed papers for scripts. So I could back up to this and it would remove all of the changes that I had in between, and it would actually add them here to this staged area. As we looked earlier at that diagram on what's staged, it would move those changes that I made back to the staged area and away from the head. I can do hard. The only difference here is just to tell the terminal that I'd like to go hard. That means to go back to the previous version and also to delete all the changes that happened in between. Do not save those changes. And git stash, this is one I probably use the most, to move the weighting changes out of the queue. So I've got, as you see here, when you have Git and GitHub installed, then you'll have a Git tab in the upper right-hand corner of your RStudio interface. And this is where you will see all the local changes that are stored but are not yet committed. And if I do git stash, I won't do it here, but if I did git stash, then it would remove these changes. Let's do now to commit the changes that I've made. So I'm going to write a commit message, and it seems what I've changed is removed the date from first slide. So, and then now that commit is gone. So you can see here there are no local changes anymore, but those are just stored in the second stage, which is they're on their way to the repository. So I could now, just for fun, make some silly change that doesn't make sense. So I'm going to save that. Now my slides won't work because this is a break between slides, right? So I try to run, there's something wrong. Now I can go here and say git stash. Git stash, and now those changes will be gone. Okay, and the date is the date back. No, everything's fine. So I'm back to the state, previous state, so that this third asterisk has been reintroduced, and now the slides break correctly. And that's it, really. And I recommend also visiting I'm going to give you another resource here, that's jennybc.github.io, and there's lots of useful information about various other command line options that you can use to communicate with your computer and tell Git what to do for your repository and how to help you manage this process. But generally, it should be possible through GitHub, and we're going to go into a lot of that, I think, together, so you'll get some firsthand experience. But do read the resources and reach out if you need any assistance with anything.